Hello everyone, welcome to yet another tutorial on building applications on the ICP network, and today is the final day of our Build an ICP series in partnership with the Code. And so today we're going to look at how you can develop a simple staking app on the internet computer blockchain using Motoko as the developing language. And so previously we covered a little bit about ledgers, a little bit about how you can interact with them. And in today's session, we are actually going to be applying everything that we covered in the previous sessions to come up with a staking application. We shall focus more on the back end, and that means this session is only dedicated to the back end, though I'm going to write an article on how you can actually integrate the front end to your staking application. And without wasting time, let's begin. And so we will create everything from scratch. And as you can see, I have my terminal open up. So I think I need to close it and open it again. So, all right, let's wait for it to load. I clear the screen. And so we will use DFX to create a new project. And I will just first, do list. We need to test folder. That's where we shall host our project, and then DFX new uh, maybe staking Dapp. So I'll just click OK, and then you'll see that I need to select Motoko as the back end, and then I can actually select no front end, and then I can just select none, and it will create for us a simple project with all the requirements that we want. And you will see that if I do cd staking Dapp, and then I open it in my VS Code, it's trying to download some, I don't know what it is, so hopefully it takes a short time to download. But basically, this is the folder that we're going to work with, and we shall develop everything from scratch. We shall first of all install our ledger canister, and then from there we will use it in our backend to create the logic for staking. And so I think it's done downloading, and we should be able to install it inside, rather to open it up in VS Code. So wait for it to load, and compatibility check successful. And here we have our VS Code open with our project. And so now that we have our project open, we need a few things, but first of all, we need to start the terminal. Can actually stop it. I think it was open sometime. DFX stop, and then I will do DFX start clean and background. So as we start, we create like a new replica which doesn't have any previous state. All right, so it's taking a little bit of time, but it should be good to go once everything is set up. All right, so as you can see, it's saying process clear remaining. So anyway, we can just do the effects background, then clean. It works. And as you can see, it has an error, but we shouldn't worry about that. I'll just clean and then open the whole thing on another port. So I just copy this, paste it here, and then change the port. All right. So once we have our new replica up and running, we should be good to go. And as you can see, we have our replica running, and on the left hand side, this is the project structure. File structure, we have a readme file, we have a dfx with JSON, which only has one canister, and we can actually rename it to backend so as it can be easy for us to type it here. Then we have the source folder where is there's only one file main.mo, and it has a simple actor class and rather actor and a function grid. We don't need this, and of course we will delete it. But the first thing now that we have to do is first of all we have to get away to install the ledger canister, since in staking the Dapp that we're going to develop, it will require users to deposit tokens, withdraw tokens, and interact with the ledger canister in different ways. So now the first thing that we have to do is actually install the ledger canister, and the way we will do that is actually going to the docs. This should be a straightforward process. Build. I already covered this in the previous videos, so I'll just be rushing through everything. If you want an extended video on how to install this ledger, you can just check out the previous videos on my YouTube channel, and also in a relationship, rather in partnership with Central Code, we have also been uploading some videos. So I will just use this guide. You see, the first thing they want us is to actually do this. So just copy this, go back, put the semicolon, rather comma, paste this here, come back. I see I need to get this, the latest version, and okay, this is I think the latest version. All right, we click on this, and then we copy this ID. So I'll just replace it here and also replace it here. So I'm done with setting up my dfx.json, and going back to the ledger guide. So I'll just scroll, 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 copy this. It shouldn't take anything. It's a straightforward process. Copy this. I'll just first paste it here. My token maybe staking token STT. I'll just cut this, paste it here. This is a straightforward process, and I won't try to explain what we are doing right away, because by now you should be familiar with everything. So you can also actually write a script to automatically deploy your token ledger canister, but this is for another video. Right now we are trying to see how we can build a staking application on the internet computer. So this is the second last step. So I will just first of all text identity, use text ID. This is the identity that I'm okay with. So just do this, paste everything here, and click OK. All right, so we give it a few seconds for the token ledger canister to be installed and deployed. And once everything is set up, we shall continue to the next step. And the next step will be actually to configure DFX so as our backend canister can communicate with the ledger canister. And the way we do that is simply by coming to the ledger canister, to the actually the backend canister definition, and then we put the dependencies, and then we specify the ICRC1 ledger canister. And in that case, the backend canister knows that we're going to use the ledger canister in our backend code. So with that, we are done with configuring the ledger canister. And so I will just switch to the main.ml file. I think I can actually close this. And here we shall begin writing our code for the staking up. The first thing is actually to define the actor staking Dapp, and this is where all our code will be. And so what we need to define a few things in relation to the staking Dapp. First of all, here is the logic of how it will work. So a person will deposit some tokens. So in our case, we shall be using the tokens from this ledger canister, STT tokens. And once they deposit the tokens at the end of the year, we give them like a percentage, maybe 4% or 8% of the total amount of the tokens that they deposited. And so that means we have to track the time that they deposited those tokens and also the amount that they deposited, so as we can be able to calculate, the rewards to give them and also the duration they have had with their token staked. And so the first thing that we have to define is actually like a struct or a type. And I'll just, say type, well, I think even if I don't put comment, so it would be public type stake. So I'll just call it stake. And then inside here, we just have the amount is of that. We just import it. We have the start time, meaning the time they deposited uh, those tokens, which was of type integer. And then we want also maybe add in another variable is text, which should be a boolean, right? So this is just a simple, struct to actually track who has deposited which tokens, when did they deposit the tokens, and are they still staking the tokens yet, or they unstake their tokens. So now that we have this struct, we also need to get a way of how to store, to associate actually the user and the information about their tokens, and rather the information in this public type. So we shall use hash map for this case, and hash map actually is like a dictionary, I think, in Python, whereby you have a key and a value pair, and that's what we're going to do with the hash map. And so I'll just maybe put a simple comment hash map to hash map store the details, why am I the details of the user. Don't worry about the misspellings, just so just solid users hash map will be to hash map, we import it dot hash map. So just it will be of type principal, that will be the key, meaning the principal address of the user. and then the value will be of type stake. So we close it. What does it require? I think it requires maybe three things. The starting value, then the principal dot equal, and then principal dot hash. Don't worry about this for now. These are like standard, and if you want to know more about them, you can just visit the documentation, and you will find all the details of why they use principal dot equal and the principal dot hash. And the reason basically is that we're having the key as a principal. If we were having the key as maybe a text oriented, we would have used a different method here and here. So with that said, we now have hash map to store our users, and the next thing is actually to define. We need a couple of other things that we need to define. One of which is the token fee, I think. Anyway, we shall define that later. So we now have to write our first function, and the first function will allow actually users to stake their tokens. And so our first function is allow users to stake tokens. All right, so public shared, we want to know the caller of this function. So func stake tokens, and we actually want to know the amount. We want the user to learn specify the amount that they want to stake, and afterwards we shall just return result dot result. If this function is successful, we shall just return nothing or empty parentheses. But if there is an error, we shall just return that error in form of a text message. All right, so now that we have defined like the boilerplate function, we have actually a few things here. We have actually to do a couple of different logic steps so as to be able to let the users take their tokens. So the first thing that we actually want to do is get away of transferring a certain amount of tokens that the user has specified from the user's account to our own account. That's the first step. And once that step is completed, or once we have successfully transferred the tokens, it will be time now to store the user's uh, data in our database, sort of, or in our hash map. So the way we do that, so we actually have to do two things. So transfer tokens from the user to the canister, which is the back end. And then if that step is successful, store the user data inside the hash map. So basically that is the logic that we need to create. And so how do we transfer funds from the user's account to our own account or to the account of the back-end canister? So first of all, as I have already told you before, we have to get away to interact with a ledger canister, and so that means we have to import it ICRC ledger. Then the way we import it is actually you specify the canister, then ICRC ledger canister. If this is the thing, let me see the naming. I can just copy it and paste it here. All right, so this is how we import the ledger canisters or external canisters. We first specify it inside the JSON and also Now you just import it as this. So if we actually click on the link for the ledger canister, you will see that it opens up in a new browser. I can actually copy it. All right, so can actually copy it here and paste it, paste it one, paste it here, and then load it up. So this is the interface of the ledger canister, and down below here you will see that we have actually a method or a function ICRC to transfer from that allows us to transfer funds on behalf of another user. So this is the same function that we are going to use, and we will transfer funds from the user's account to our own account, and that means the user has to first approve us before we do that. Otherwise, the function will fail. And so back to our code, I will just write a simple function that will help us do that. And the way we do that, maybe helper function function transfer funds from the user. So it will be a private function. So transfer funds from user. So we just need the user first of all, which is of type principal, and the amount that we want to transfer on their behalf, which is of type NAT. So if the transfer is successful, we shall just return a boolean true, and if the transfer has failed, we shall just return false. So inside here, this is where we're going to use our ledger canister, and the way we do that is actually transfer results equals ICP ledger dot ICRC transfer from. So it takes in a couple of things. So it has to be an await since it is asynchronous. And if you check right here, let me first open up the second uh, tab, and then we need to check out the ledger canister that did ledger canister. So the transfer from, check out the transfer from the arguments. So right here you will see that these are the arguments that this function takes in. So we shall just come here. So I can actually spend account, it's optional, so I'll just leave it as null. Spend account equals null, account equals null. So from equals is an object of owner equaling to user, and then sub account, which is optional, would be null since we are transferring the funds from the main uh, account. Then the two is also an object, so owner equals principal dot from actor of this. So meaning we are targeting the principal of this backend canister, and sub account will be equal to null. And so there are a lot of errors right now. So I think we can just mispress await. So right, so I need to put here sync if the await is to work, and mispressed await. Why are they saying that? So the issue has gone off. We have this error right here that says this is not defined. And for this to work, we have to actually change our actor definition to a class. So put this and add add this right here. So the error should move away, and as you can see, now we have a different error. So we can just see if it's working. You will see that if we try to return something, this error should move away. And as you can see, we have not finished all the parameters. We were on the second one, and so we continue. The amount, of course, will be amount, amount, okay, and fee will be null. Then memo will also be null, and created at time will also be null. All right. So I think some errors should move away. And what are they saying? Uh-huh. Spender account. All right. So spender account. Why are they flagging it? They're saying it's spender sub account. Yeah, not spender account. Sub account. All right. So I think we should be good to go. I format the code, and let's see now where the error is. Okay. Missing spender sub account. So the error has moved away. And so basically, if you check back here on the transfer from function, it returns a result of this type. And if you have to check this type, you will see that it's either an okay or an error. So we also have to cater for that. We want to check if the transfer has been successful. That's when we shall return true. If the transfer has failed, we shall return false. So we're going to use switch, and then get this here, put it inside here, and then we check for okay of any value. If we have an okay, that's when we shall return true. If we have an error of any error, we shall just return false. And so this function will actually help us to transfer funds from the user's account to our own account. And so this completes our definition of this function. And as you can see, there's no error in this function, so we are good to use it in our code. So the error is saying unidentified, meaning we have not used it. And so now we have written a helper function to actually help us transfer funds from the user's account to our own account. And back to our stake tokens function, we will actually use this function that we just created, and the way we do that is very simple. Is we got a way to transfer funds from the user. All right, so it takes in two parameters, a caller and amount. So that's okay. We have to check whether the result is true or false. The result from this function. So if result, what should we do? We should do something. And then if it's false, we should also do something. You get that? So pretty straightforward. So If the transfer has been successful, meaning that we have transferred uh, tokens from the user's account to our own account, it's at this stage we need to store the information in our user's hash map. And so I will just copy this and paste it here. Then we use the put method, the key being the caller, and then the value will be of type this type. So the amount will be the same amount that we transferred from the user. The start time will be the time dot now. So time dot now is actually in the base library and allows you to get the current time, I think in nanoseconds. Yeah, in nanoseconds, and then its text should be true. And then once we've stored the data from the users into the user's hash map, can just return an OK, meaning everything has been set and there is no issue. So that is in a scenario where the tokens were transferred successfully. But if the tokens were not transferred successfully, meaning the user has nothing to stake, and we shall just return an error saying unable to stake tokens. Maybe the user has not approved us to transfer the tokens on his behalf. So we shall just return this, and then we won't do anything with the like storing anything in the user's hash map. And so that's the first function. So this function means the user can actually stake tokens, approve. So the flow is simple. If they want to stake tokens, they will approve us to transfer their tokens on our behalf, and they will call this function specifying the amount that they want to stake. Once they have called this function, we shall just use this helper function. We transfer the tokens from the user's account to our own account, and then we shall store the information in the database. All right, I think that is it for this function. You can actually put this comment up here. All right, so hopefully it works. So that's the first function with its helper function. And the other function is actually which other function can we write? So the second function should be to do what? To claim rewards, right? So the users the user has taken their tokens, and by default the stake tokens should be um, getting some rewards since they are staked. And so in this part, we're going to write a function that allows users to claim their rewards from the tokens that they have staked. And so allow the user stake to actually claim the rewards. Cool. So it will still be public shared caller function claim rewards. It doesn't take in any parameter. It's an asynchronous